So this is a review video, not a flip video, to help my students understand some of the topics that I did for integration techniques. So let's start with how you deal when you have an integral with a tangent odd power. So if you look at this integral, the power is odd, it has a tangent, and the secant power is also odd. Well, if the secant power is even, you already have a nice technique for secant even. So this time we are dealing with tangent odd power and a secant partner, which is also a secant odd power. Okay, and so the first thing to do would be to reserve a tangent x, secant x. Okay, second step would be to convert everything into secant by using tangent squared, secant squared minus is equal to secant squared minus 1, and the third step is to put u equals secant x. Now let's try to see what these things mean. Okay, and so let's look at step 1. So step 1 is actually we have your integral, right? Okay, step 1 would be to split and reserve a tangent x secant x. So from the integral I will reserve a tangent x secant x at the end. Okay, and see how I reserve that. So now one tangent x is gone and the secant x is gone. So the secant x is gone, one of the tangent x's is gone, so you're left with the tangent squared. So you have tangent squared, okay, and we have the reservation. That is step 1. Step 2 is convert everything else to secant, So we need to convert everything else to secant. So what is everything else? So we have only this now because we have already reserved this. We need to convert this into secant. Now we know that by Pythagorean second identity, that secant squared is equal to tangent squared plus 1. So tangent squared is equal to secant squared minus 1. So we replace tangent squared by secant squared x minus 1, and then we have tangent x secant x at the end. Okay, so once again the first step is to reserve the tangent x secant x, but once you reserve that, okay, that's the green stuff, right? Look at the black stuff, the remaining black stuff you convert to secant by using the identity tangent squared is equal to secant squared minus 1. That's what's here. Okay, and now the third step is that now you can see that everything is in secant except this part, but that's the derivative, right? So that will get cancelled off eventually, but this part, the black part, everything is secant now. So you put u equals secant x. So when you put u equals secant x, so then you get this part will be what? U squared, then you have minus 1. So what is this? Now if u is equal to secant x, we know that the derivative of u, which is du, would be equal to secant, let me write it here, secant x tangent x, sorry, dx, right? So that's the derivative. So this part right here is actually du, the derivative of secant x. Okay, so what we do now is to put u here. So this becomes u squared minus 1, and this is actually what? That is just du. Okay, so u squared minus 1 and du. And now everything is in u, there is no x here, so we can integrate. So the integral of u squared, of course we can use power rule, and you get u cubed over 3 minus, what's the integral of 1? The integral of 1 is just u. So we are now done with the integration, right? So we have I is equal to u cubed over 3 over u. The final step is to actually plug back for u, but we know that u is equal to secant x, so it will be secant cube x over 3 minus u is equal to secant x. Alright, so that's how you do a problem which has a odd tangent power and an odd secant power. Okay, so once again the first step is to reserve a tangent x secant x, and then whatever that is remaining, convert it into secant. Okay, and then put u equals secant x, and then this becomes just du, and then integrate and then plug it back. Okay, it's a short video, but I think that's the essence of any other problems that you get of this type.